I watched a lot of videos about assembly tables and laser enclosures before coming up with my final design, but of all the ones I saw, none of them had this. So stick around to see how I made it, and you might want to grab yourself a cuppa. We've got a lot to get through. The lift assembly of this laser enclosure had to be the most accurate part of the build, because one part had to slide inside another without any slack, but also without binding. So it made sense to me to build it first, get it right, and then build the rest of the table around it. I started by cutting up some off-cut melamine to the height that I wanted the inside lift part to be, and screwed them together into a simple box. I then cut up more boards to make an internal support structure using halving joints. This would make it very rigid so it keeps its shape, and also provide the surface for the lift mechanism to push against. I didn't use a solid board as a base because the ventilation for the laser enclosure will draw air up from the bottom, through this section, through the honeycomb, and out through an extractor fan at the top. My original plan was to have the entire surface of the inside sleeve slide against the outside box, but then I thought that was way too much surface area, which could cause excessive friction. So I used these strips of flooring material, which have a very hard and very smooth coating, to act as bearing pads between the two parts. The internal support structure wasn't the full height of the box because I didn't want it being burnt by the laser through the honeycomb bed, which meant there was no support in the centre. So I used these extra long bugle head screws set at the right height, and they worked out perfectly. With that done, I could now make the outside box, which I did from more offcuts of melamine. Some pieces weren't big enough and had to be joined together, which was fine because this was an opportunity to use up material I already had. I made the outside box by essentially wrapping the boards around the internal slider, if that makes sense, rather than making the box the conventional way, which would require cutting boards very accurately to exact length. This way makes it easier to get accurate, and when it's done, just use a flush trim bit to trim the overhangs. I used the thickness of one business card in each direction to give just enough tolerance for the lift to slide, with no racking or binding. This assembly table is going to be mobile, so I took the opportunity wherever I could to keep the weight down, such as cutting away excess material wherever I could. Every little bit counts, right? I could now start constructing the laser enclosure, and that started with these wings attached at the top edge of the outside lift box, and these will be the base where the laser will sit, and then the outsides of the enclosure would be screwed to the outside edge of the wings. I gave the inside of the enclosure a good coating of poly to hopefully protect it from the smoke being generated by the laser. With the wings in place, I could then start attaching the sides of the enclosure, but first I had to cut out the viewing windows for some tinted perspex. I made the long cuts using the table saw. And then finished them off with a Forstner bit and the jigsaw. I made this very simple right angle template to route the corners and the ends of the window straight and square. Then it was outside to cut the recess where the perspex would sit because I knew this was going to make a lot of dust. A quick round over to smooth the sharp edges, squared off the corners with a chisel, and I was ready to start gluing and screwing the sides in place. I made sure to drill a pilot hole for every screw in this build. It might take a little longer, but it's necessary to avoid any splitting when screwing into edges, which I can confidently say never happened. You can also see how I use small offcuts as a second pair of hands to help position the pieces in place and keep the mating edges flush. The lower section of my old router table with the bit trays and the drawer was perfectly fine to be reused, and I put together these two boards as an insert to form the router enclosure, with the old drawer assembly mounted underneath it. I positioned the old drawer assembly in its new location to mark for screw holes and drilled them out. I then disassembled the base of the router enclosure to fix it to the top of the drawer assembly and then put everything back together again. With the drawer assembly in place, I could now trim the outside box of the laser lift to match. It was left longer than needed for this reason. I transferred the levels across to the box and then trimmed it down off camera with a straight edge and circular saw. These two items needed to be at the same level so I could fix a baseboard across the two. Time to make the legs and the base, and for that I used some old reclaimed jarrah from my timber stack. I found these two lengths that used to be roof rafters. I cross-cut them to length a little oversized and then ran them through the usual milling process of flattening one face on the jointer and then through the thicknesser to flatten the other face parallel. I then glued the boards together in pairs to make the leg blanks. While they were drying, I milled up this old board and ripped it down the middle to make the stretchers that will tie the two leg assemblies together. Once the leg blanks were dry, I milled the other two faces on the jointer first and then through the thicknesser. I trimmed the legs to final length and added a chamfer to get rid of the sharp corners and to prevent them from chipping out. Next step was to cut out a very long rebate in the top of each leg for the sides of the assembly table to fix to. I made the shoulder cut on the table saw first and then removed the majority of the waste on the bandsaw. I didn't want just a straight butt joint between the leg and the side carrying all the way to the table. To clean up the surface of the rebate, I made this very simple router jig. And used this awesome flattening bit. This setup worked perfectly. To install the stretchers to the legs, I cut a groove near the base of each leg, which would make a much stronger connection than a straight butt joint. And I reckon it looks better too. Again, I made sure to drill pilot holes for the screws, especially in this very dense old hardwood. And I used some beeswax on the screw threads too, which makes it a lot easier to drive them in. Before fixing the legs and base assembly to the table, I needed to paint any areas I wouldn't be able to get to afterwards. With that done, I could now install the legs and the two long stretchers that would tie the sides together and support the underneath of the table. I was worried about the strength of the joint between the MDF and the hardwood where the screws went in, so I used these perforated metal fixing plates. I could have also used mudguard washers, I suppose, but these look better. At this point of the video, I'm starting to think that this table may be a little over-engineered. Time to give the table its final coat of paint. And that brings us to the lifting mechanism. Unfortunately, I don't have any footage of making this because what you see here was built as a prototype to see if my idea would work, and I would then make a better, more refined version. But this one turned out so well that it didn't make sense to make another one. For those of you that have watched my belt grinder video, this motor here came out of the same treadmill. This is the motor that was used to raise and lower the treadmill bed. It's the perfect application for this because it has this long threaded section and it's geared down to just the right speed. Also, it's wired as a reversible motor, so I just needed to attach it to a simple up-down switch. I cut out any excess material that wasn't needed on the lift platform to allow for airflow up through the laser enclosure and to save a little more weight. I got the perspex for the windows, so I installed that first before fitting the lift mechanism in place. This is just dark tinted perspex, it's not laser rated. I'm very happy with how this has all come together so far. I installed the laser in the enclosure and added some ducting to tidy up the cabling. The top of the router table where the router would be mounted was made of 2 layers, an 18mm MDF layer with a 16mm melamine layer on top. I marked and drilled out screw holes to attach the 2 panels together and installed screws around the perimeter first, and would come back later and add more after cutting out the hole for the router. I used the top from my old router table to mark out the hole and used a circular saw and a hand saw to cut it out. That little overrun there, that'll be covered by the router plate, and I cut the recess for that next. I just used a board as an edge guide and a straight bit in the router set to the right depth to cut the recess. That's a pretty nice fit, I reckon. I drilled the holes for the mounting screws. Attached the threaded inserts, and that was that done. The lid for the laser enclosure is big, and originally I was going to make it 2 layers thick like the top of the router, but I was concerned about the weight of it being too heavy to lift, so I made this framework instead from 18mm MDF to sit under the lid. This would bring it up flush with the router top, still give the lid some rigidity, and help to keep the weight of the table down. Remember, every little bit counts. Making the frame was fairly straightforward, so I'll speed through that. I built the frame in place, temporarily screwing it down to ensure a perfect fit. All the joints were glued and doweled for extra strength, and I used the Dowmax, of course, for perfect flush joints. Once all the joints had set, I removed the frame and gave it a coat of paint. When the paint was dry, I could fix it permanently to the underside of the lid. I attached the lid with a continuous hinge or piano hinge with these little flathead stitching screws, which are perfect for this application, and they're far better than the screws that come with the hinge. Pretty happy with that. I had to install an access door into the router enclosure, so I made up a quick cutting guide and screwed that in place. And off camera, I roughly cut out the majority of the hole with a jigsaw and finished it off with a flush trim bit. I cut a small piece of MDF to size as the door and attached it with some butt hinges. I made a DIY latch to keep the door closed. Then gave it a coat of paint, added a door stop and a door pull, and that was done. The final touch was an external on-off switch. A good trick to use if you're having trouble cutting holes with a hole saw, especially larger ones, is to cut a relief hole on the edge of the hole saw kerf. This allows the sawdust to exit the cut and not clog up the teeth, which makes a cut a lot better. I didn't have the exact size hole saw I needed for the extractor fan, so I cut this template using the laser and used it as a guide for a flush trim bit. That's a perfect fit because the fan wasn't going to be attached permanently to the table. I wanted it to be easy to attach and remove the fan from the table, and I'm relying on a friction fit for that. When not in use, it'll be stored away, and as you can see, it's ducted straight out through the shop window. I was thinking that I would just fix the router top down by just screwing it in place from underneath, but then I had the brilliant idea of hinging it as well, which would allow for easy access into the top of the enclosure and also to the vise and electrical connections. The top is locked in place with these large screws into threaded inserts on the underside of the top, and they're screwed up through the mounting block for the vise. I also made my own quick connect system for the router table dust extraction because I wanted that to be easily attached and removed as well. I didn't include making the quick connect system in this video because I was just worried about it getting too long, as well as the vise install. I didn't include that either. This vise install was very unique just to this bench, and to be honest, it probably wouldn't have been any help to anyone wanting to attach this kind of vise to a regular workbench. But I will add links to my video that I made when I first got this vise and installed that to my old workbench. I don't have a fence on the router table yet, but I do intend using my old fence from the old router table. I think that will work just fine. Probably add a T-track here and here, I think, and that way I can just put a couple of hand knobs there and there to tie that down, and that can slide back and forth. So that's the plan for that. The bench is intended to be mobile, but to be honest, it will probably sit here forever and never move. But I still did make a caster system for it. I didn't want it sitting on casters all the time. I wanted it sitting solidly on the ground. So I made this retractable caster system. I didn't go into that either in the video. Again, I just thought this would take too long. And there are many, many videos online about this system. That's where I got the idea from, but it works just so brilliantly. And I'll give you a demo now how it works. I have a set of these at both ends of the table. Now I can barely lift this table on my own, and even two people would struggle to move it. But with the power of leverage, I can basically lift each end with one finger and move the table if I need to. I haven't bothered coming up with a latch system yet, because as I said, I don't see myself moving this very often. Well, thanks for watching. I hope you enjoyed that video, and I'll see you in the next one.